Okay, so good day. So for this video, we will be discussing solution of differential equations. So particularly um, the first type, so which is variable separable differential equations. Okay, or commonly known as separation of variables. Okay, so in this type of differential equation, we group the variables. Okay, and then after we have grouped the variables into um, each term, okay, so then we can proceed directly with integration. Okay, so kung sa Bisaya pa, so ato ang itapok si x and si y. Okay, so that's what it means. So we will group according to variables. So of course, we will be using our knowledge of algebra. Okay, so we will express this, okay, in terms of a term containing the y variable only and another term containing the x variable only. Okay, so that's why it's called separation of variables. So in that way, if the variables are already separated, then we can integrate each term individually to get the general solution. Okay, so for this example, so we have dy over dx is equal to y squared plus xy squared over x squared y minus x squared. So by the way, forgot to read the problem. So find the general solution of the differential equation. This one. Okay. So since this is the first type and there are several types of differential equation, so this is the first thing that you are going to test. Okay. So when you are presented with a differential equation, you don't actually know what type of solution would you use. Okay. So you have to test it by trial and error. So the first type, you test it if it belongs to the differential equations that can be separated, okay, in terms of their variables. Okay, so again here you have dy over dx is equal to y squared plus x y squared over x squared y minus x squared. Okay, to separate the variables, so the first thing that would come into mind is factoring. So let's see the numerator here. So we have a greatest common factor of y squared, and here we have a greatest common factor of x squared. So let us try first factoring. So dy over dx is equal to, so factoring y squared in the numerator, so that would be y squared. So if we factor out y squared, so what will remain is 1 plus x. Okay, and then in the denominator, we factor out x squared, so what will remain is y minus 1. Okay, so with that we can now separate. Okay, we can group 1 plus x over x squared and y squared over y minus 1. So we'll have dy over dx is equal to, so the first will be 1 plus x over x squared multiplied by y squared over y minus 1. Okay, so that should also include dy and dx. Okay, so we group dx with the terms containing x, and we group dy with the terms containing y. So how would we do that? So we can multiply and divide both sides of the equation by, okay, so how do we do that? So multiply this side by dx. Okay, multiply also the other side by dx. Okay, so dx here will cancel out, so we will have dy is equal to 1 plus x over x squared times y squared over y minus 1 dx. Okay, so however, so y is still on this side and we need to transfer that on the other side. Okay, so what we can do here is we can divide both sides by, y squared over y minus 1. Okay, for this side, on the other side, divide it also by y squared over y minus 1. Okay, so we can cancel out this. Okay, and then if we simplify this side, so dy over y squared over y minus 1, so this will become y minus 1 over y squared dy is equal to 1 plus x over x squared dx. Okay, so as you can see now, so our terms are already grouped in terms of variables. So as you can see, this term is composed only of y's, and this term consists solely of x. Okay, so we can now therefore proceed to integration of each term. So all we need to do is integrate both sides. Okay, so we can now integrate. Okay, so but before we integrate, so we can simplify this one. So this will become the integral of y squared, y over y squared, so that is 1 over y, minus negative 1 over y squared, so that is 1 over y squared, is equal to, on this side also, integral of 1 over x squared, and then plus 1 over x, okay, dx. Okay, so integrating both sides, so first term, here we will have logarithmic, and here we have power formula, then here power formula, and here logarithmic. Okay, so integral of 1 over y dy, so that is ln of y, minus integral of 1 over y squared, that is y raised to negative 2, right? So therefore we'll have y raised to negative 2 plus 1 over negative 2 plus 1. Okay, so is equal to, so integral of 1 over x squared dx, so similar with this one, so we will have x raised to negative 2 plus 1 over negative 2 plus 1, okay, plus integral of 1 over x dx, so that is ln of x. Okay, and since we have finished integrating, so this is an indefinite integral, so we'll have plus c. Okay, so where the c is the arbitrary constant. Okay, so simplifying this, so this will become ln of y, this will become minus over negative 1, so that will be plus 1 over y. Okay, so is equal to, this will become negative 1 over x, okay, plus ln of x, okay, plus c. Okay, so this is already an acceptable form of the solution of the differential equation. Okay, so this is a general solution, okay, only because we were not given with conditions of x and y so that we can solve for c. Okay, so it's only a general solution. So if we know the value of c, if we can solve for the value of c, then it is already a particular solution. So this is a general solution only. Okay, so let's have another example. Okay, so for our next example, so find the particular solution of cosine of y plus, so we have the quantity of 1 plus e to the negative x multiplied by sine y multiplied by dy over dx is equal to 0. So given that y is equal to pi over 4 when x is equal to 0. Okay? So again, so first step is to see if the differential equation is variable separable. Okay? So, we should combine y, right? We should combine x. Okay, so this should be, so how would we proceed? So we can first multiply both sides of the equation by dx. So cosine of y plus 1 plus e to the negative x sine y times dy over dx is equal to 0. So multiply both sides of the equation by dx. Okay, so if we multiply dx, so this will become cosine of y dx plus, if we distribute dx, so dx will cancel out, so this will become 1 plus e to the negative x sine of y dy is equal to 0. Okay, so next we should eliminate cosine y in here and eliminate 1 plus e to the negative x in this side. So therefore, we can divide both sides of the equation by cosine y times 1 plus e to the negative x. Okay, so whatever we do on the right side of the equation, so we must also do that on the other side of the equation. So divide this by cosine y times 1 plus e to the negative x. Okay, so obviously nothing will happen on the right side of the equation, but we still need to show that step. Okay, so dividing, so cosine y dx divided by cosine y times 1 plus e to the negative x. So what will remain is dx over 1 plus e to the negative x. Okay, on the other side, so we can cancel out this factor 1 plus e to the negative x. So what will remain is, so plus sine y dy over cosine y, okay, is equal to 0. Okay, so we can now proceed to integration. So since we've already separated the variables, so in this side we have, in the first term we have variables of x only, on the second term we have variables of y only. Okay, so integrating both sides. Okay, so integrating both sides, so as we can see, we can integrate directly the second term. However, the first term may require the use of algebraic substitution. Okay, so let's integrate this first. So let u is equal to 1 plus e to the negative x. So transposing on the other side, so we will have u minus 1 is equal to e to the negative x. And then taking the natural logarithm of both sides, so we will have ln of u minus 1 is equal to ln of e raised to negative x. And then using the properties of logarithm, so ln of u minus 1 is equal to, so we can transfer this in the coefficient, so negative x ln of e. Okay, so but we know that ln of e is equal to 0, so therefore we can also transfer the negative sign on the other side, so we will have negative ln of u minus 1 is equal to x. Okay, and since we will be needing dx, so we'll differentiate both sides of the equation. So the differential of ln of u minus 1, so that is negative differential of this over this. So differential of du minus 1 is du over u minus 1. So that is equal to dx. Okay, so by substitution, so we can write that here. So therefore, the integral of dx over 1 plus e to the negative x is equal to the integral of du is negative, dx is equal to this one, negative du over u minus 1 over 1 plus e to the negative x, so that is u. Okay, so this will become negative, taking out the negative sign, negative integral of du over u times u minus 1. Okay, so how do we integrate that by partial fraction decomposition? So we will have 1 over u times u minus 1 is equal to a over u plus this is b over u minus 1, right? So from your integral calculus, so cross multiplying that, so you will have 1 is equal to a times u minus 1 plus b times u. Okay, so next, so since this is distinct linear factors only, so then we can substitute values for u so that we can solve for a and b. Okay, so at x is equal to, so first is we need to equate the factors to 0, so we will have u is equal to 0 and u minus 1 is equal to 0, so therefore we can use two values at u is equal to 0 and u is equal to 1. At u is equal to 0, so this will become 1 is equal to a times 0 minus 1 plus b times 0. Okay, so obviously we can cancel out b, and then we will have here a times negative 1 is equal to 1, so therefore a is equal to negative 1. Okay, so next at u is equal to positive 1, so this will become 1 is equal to a times 1 minus 1 plus b times 1. Okay, so this will become 0, so therefore b is equal to 1. Okay, so therefore this integral now here, okay, will become, so let me get another sheet of paper. So this will now become so the integral of the negative integral of du over u times u minus 1 is equal to the integral of, so this one, a over u, so our a is negative 1, so negative 1 over u plus our b is positive 1, so plus 1 over u minus 1, okay, du. So therefore we can now integrate that, so that will become sorry, I forgot the negative sign here, so we have a negative sign outside the integral sign, so this will become negative, so integral of negative 1 over u du, so that is negative ln of u, okay, plus integral of integral of du over u minus 1, so that is ln of u minus 1. Okay, so therefore this will become ln of u minus ln of u minus 1. Okay, or we can apply the quotient rule of logarithm, so this will become ln of u over u minus 1. Okay? So, but since from our substitution, our substitution earlier, we have u is equal to 1 plus e to the negative x. Then we must substitute that back. So this will become ln of u is 1 plus e to the negative x over 1 plus e to the negative x minus 1. Okay, so simplifying, that will become ln of, so 1 will cancel, 1 over e to the negative x, so that will become e to the x, and then e to the negative x over e to the negative x, so that will become 1. Okay, so that was actually very simple answer. So we're not expecting that. Okay, so if we have rewritten this as 1 over e to the x, then we could have avoided the substitution. So, but since we've already done substitution and the long method of partial fraction decomposition, so you have at least recalled your partial fraction decomposition and your algebraic substitution. So you notice that we haven't added a constant here. Okay, so because we were not finished integrating yet. So therefore, this is the integral of dx over 1 plus e to the negative x. Okay, so that is only one. We've only integrated this part. Okay. So on the other hand, so integral of sine y dy can be integrated using the natural logarithm. Okay. So where the numerator is the complete differential of the denominator. So since our denominator is cosine y, its derivative or differential is negative sine y dy. Okay, so for us to integrate this, so we must place a negative sign here, and then outside the integral sign, we will put minus. Okay, so therefore, this now will become, so if we rewrite the integral, so the integral of dx over 1 plus e to the negative x plus the integral of sine y dy over cosine of y, okay, is equal to 0. Okay, so again, the integral of this is this, so therefore we will have ln of e to the x plus 1, and then this one, so what we did here, so we put negative sign. Okay, so to complete the differential, so therefore it will become negative ln of cosine of y. Okay, is equal to, so since we're finished integrating, so we will add an arbitrary constant, so is equal to c. Okay, so this is now the general solution, or we can simplify it further by combining this. So we will have ln of e to the x plus 1 over cosine of y is equal to, so let's say, so we also express it in terms of natural logarithm, so let's say c is equal to ln of c1. Okay, so then it will become ln of c1. Okay, so since both are in logarithm, so therefore e to the x plus 1 over cosine y is equal to c1. Okay, or you can express it as e to the x plus 1 is equal to c1 cosine of y. So this is now our general solution. Okay, so this is still our general solution because we haven't determined yet the value of the arbitrary constant C1. Okay, so we can solve that value of the arbitrary constant by looking back here. So when y is equal to pi over y is equal to pi over 4 when x is equal to 0. Okay, so at x is equal to 0, y is equal to pi over 4. Okay, so substituting that in here, substituting x is equal to 0 and y is equal to pi over 4, so then e raised to 0 plus 1 is equal to c1 cosine of pi over 4. Okay, so e raised to 0, that is 1, plus 1, that is 2, is equal to c1 cosine of pi over 4. So you can solve this without using your calculator. So pi over 4 is 45 degrees. Then cosine of pi over 4 is square root of 2 over 2. Okay, so therefore we can solve now for c1. So solving for c1, so cross multiplying 2 there and then dividing both sides by square root of 2. So therefore c1 is equal to 4 over square root of 2. Okay, or we can rationalize that. So times square root of 2 over square root of 2. So we will have 2 square root of 2 over 2. So that will become 4 over 2. So 2 square root of 2. Okay, so therefore our particular solution is this. Okay, we just substitute c1 is equal to 2 square root of 2. Okay, so therefore e to the x plus 1 is equal to 2 square root of 2 cosine of y. Okay, so that's I think that's it. Okay, so this problem was very lengthy in solution. Okay, so because we haven't realized that we can rewrite this one into 1 plus 1 over e to the x. Okay, so if we have realized that earlier, so we can have avoided this long method. Okay, so let me just illustrate. So why is that? Because if we I'll just write here. So if we rewrite that as dx over 1 plus 1 over e to the x. Okay, so then we can add the denominator, integral of dx over, this will become e to the x plus 1 over e to the x, right? And then simplifying that, so multiply by the reciprocal of the denominators, it will become integral of e to the x dx over e to the x plus 1. Okay, so which is basically ln of e to the x plus 1. Okay, so we could have avoided that lengthy solution for the integration of the first term. Okay, so that's all for this video. Okay, so kindly review your integral calculus. As I've said before, that your knowledge in integral calculus will be used in this subject. Okay, so that's all. So thank you for watching.